Hi everyone, this is Miss Ward. Tonight your notes are going to be on our last concept, Concept 7. And just so you know, this concept will be a super short concept, nothing to really worry too much about. I'm actually going to eliminate part of this concept as we talk about it. So this is really just talking about range and air resistance. This slide keeps getting messed up. So the equation, the boxes, the stuff looks all crazy on it. But I actually want you guys to ignore the equation anyway. The equation that I give you here is the equation for range. Range is just another way of saying the x distance. But the thing about these equations, this equation in particular as we're going through it, is this is another way of calculating your x distance. So it's valid, you can use it, but it's more overly complicated than it needs to be. It's one of those things where it combines many equations into one to allow you to solve something in one step, which, can be easy, but generally, like an equation like this, it's more complicated to explain than it is convenient to use. So after having gone through all of this and doing all these practice problems, I decided that I'm not going to worry. You're not going to do a problem that involves this equation. The only information you really need to get from this concept is the fact that range means the x distance. So the example they give here, how far can you throw a football down the field? Well, that depends on the angle and the speed which you throw it, which makes sense. At this point, we've done lots of problems where it depends on the angle and the speed, depends on how far your x distance is going to be. That x distance, the word we use for it is range. You've seen that in a couple of problems. You guys have asked me what range is. It's simply the x distance. And the other thing to know is that the maximum range will occur when the angle is a 45-degree angle. All right, and that just has to do with that's the point where it maximizes the angle up and down. It's halfway up, so it's going to allow it to go the furthest that it can. The only other slide in this concept is just on air resistance. So at this point we've talked a lot about projectiles. We mentioned at the beginning that we're ignoring air resistance. And that's basically what this is just saying, is the air resistance or other forms of friction, because air resistance is just a type of friction. They don't act on ideal projectiles. Most everyday projectiles are good approximations of this ideal case. Things like, for example, a football, it's not going to experience a whole lot of drag or a whole lot of air resistance unless there's a lot of wind or something else that's acting against it. For the most part, when we approximate and say that these are ideal cases, it's a pretty close approximation to what actually happens in real life. Whenever you do have a significant amount of air resistance, though, the result is that the range is reduced, so it can't travel as far away, which should make sense. If something is pushing against it, it's not going to travel as far. That's it. That's the whole concept. Like I said, nothing complicated, nothing crazy. Make sure you go on, you do that last whisk. I'll be checking your concept 6 and 7 both on Friday. You'll be taking both 6 and 7 quiz. You need to make sure you have all your practice problems done as well. So go through your whole packet. Your entire packet should be filled out, as well as all of your online forms. We'll be having our test on Monday and Tuesday. So if you have any questions, you need to make sure you bring them to me before then. All right. Have a great night.